Today is the 16th of January, 2026. We look at a world transformed by a single decade of accelerated warmth in Antarctica. The most immediate and unavoidable outcome is now part of our daily lives. The vast frozen continent has shed its ice into the ocean at a rate far faster than anyone had predicted. This has caused a measurable and significant rise in global sea levels, permanently altering coastlines around the world. The familiar shapes of our continents, drawn on maps for centuries, are no longer entirely accurate. This is the new reality, not over centuries, but within years. The first changes are subtle, the later ones are not. By the end, the world still functions, just differently. The scale of Antarctica is difficult to comprehend. It is a continent of ice, holding over 2/3 of the planet's fresh water, locked away in a sheet miles thick in places. For millennia, its immense cold acted as a global thermostat and a guardian of sea levels. Its glaciers crept with geological patience. The decade of warmth disturbed this ancient balance. It is like placing a block of ice the size of a country into a slightly warmer room. Small temperature changes created a steady trickle that accumulates, with profound consequences. The world is intricately connected to this polar region. The food we eat, the goods we transport, and the stability of our homes depend on the predictable behavior of Antarctic ice. Now that predictability is gone, a chain reaction ripples outward into systems we rely on every day. Understanding this chain is about clear, tangible facts, and a deliberate response to the world as it is now. First, low-lying cities. Second, the ocean's conveyor. Third, the weather patterns we plan our lives around. This did not arrive with a crash, but with persistent water and the need for patient, practical work. The first and most direct consequence of accelerated Antarctic melting is the rise in sea level, which has led to persistent coastal flooding. Not a dramatic wave, but a slow, permanent encroachment of the sea upon the land. When land-based ice melts into the ocean, the water volume in the basin increases. Over the past decade, this has raised the global average sea level just enough to widen vulnerability. The high tide mark is higher. Rare king tides are more routine. Water pushes up through drains on clear days. Basements hum with pumps that never used to run. Salt and saturation corrode, buckle, and kill. An irreversible step is the contamination of freshwater aquifers by intruding seawater. Once salt enters, it is extraordinarily difficult and expensive to remove. Towns lose land and local water, forced to rely on desalination or distant supplies. Property values shift. Major ports face disruption. People begin moving inland. Coastlines concentrate people and infrastructure. Redrawn maps demand redrawn plans. The first domino, sea level rise, has fundamentally redrawn the map of human opportunity. Pause. Observe. Adaptation starts where the water meets the street. What was fixed is now a moving boundary we must track and plan around. The second system is the complex network of ocean currents. Antarctica drives this circulation as cold, salty water sinks to the abyss. That deep flow pushes the global conveyor. A surge of fresher meltwater makes sinking harder, acting like a brake on an ocean engine. You feel it in nets, lighter loads, or unfamiliar species. The water feels different to the hand. Currents weaken or shift, forcing route changes and added fuel burn. Ecosystems tune to narrow ranges cross thresholds. Bleaching can take decades, or centuries, to recover, if at all. Loss of a major reef is a permanent loss of biodiversity and protection. The conveyor also carries heat. Slow it, and heat redistributes. Some regions see warmer surfaces that feed stronger storms. Others stop cooling as before, bearing prolonged marine heat waves. Change the currents and you change the planet's energy accounting. The second domino reconfigures heating and cooling, echoing from plankton to ports. The surface looks calm. The deep has changed course. Antarctica's cold strengthens the gradient that drives jet streams. A warmer pole narrows that difference, weakening and wobbling the jets. Weather feels stuck. Heat that lasted days now holds for a week. passing rainstalls, piling water where drains were sized for motion. Fields flip between cracked and drowned. A basin once fed by reliable winter storms slides under a persistent ridge instead. Over a decade, moisture depletion, failed harvests, abandoned farms tip land into desert-like states, and recovery becomes monumental. A wobbling jet links droughts and floods across oceans. It complicates planting calendars, water management, and insurance risk everywhere. Longer extremes become more frequent. Then a breath. And another pattern sets. The unsettled sky adds volatility to daily life, demanding attention without drama. Plan, adjust, repeat. In the face of interconnected change, pause and observe with clarity. One after another, the dominoes fall, not as spectacle, but as sequence. The decade of acceleration marked a transition, not an end. Armed with data, engineers build higher seawalls and living shorelines. Mangroves and marsh grasses return where they once held coasts steady. Cities redesign space to coexist with water. Farmers plant for variability, not averages. Resilience builds in meeting rooms, labs, and work sites, not headlines. Earth moves, roots take. Ordinances update. Time, investment, and shared understanding turn plans into defenses. It is happening, steadily. Shock gives way to sober problem-solving and useful invention. Reflection restores focus for the next chapter. And the work continues. Thinner shelves let warmer, deep water reach glacier bases. Undercutting retreats the grounding line inland. Each retreat exposes more ice to heat, accelerating the process. Surface dramas reflect deeper undermining. Once the grounding line passes a ridge into deeper basins, retreat can become unstoppable. Bedrock sloping inland increases exposure and speeds collapse. Trigger the instability, and sea level rise is committed for centuries. Even if air temperatures stabilize, deep ocean heat keeps the retreat going. Today's defenses are first steps in a multi-generational project. The feedback loop defines our long relationship with rising seas. Drip by drip, the future arrives steadily. Measuring well is managing better. Trends inform the build order of our defenses. From dunes and reefs to levees and gates, layered risk management. Daily life proceeds across designed, flood-tolerant ground. Global trade felt the sustained pressure, rerouted currents, volatile weather, longer, costlier trips. Ports fighting floods lose efficiency. Delays ripple to shelves and production lines. Not a crisis spike, but grinding friction. Heat waves raise baseload cooling demand, while storms threaten lines, substations, and coastal plants. Stress from demand and supply sides increases outage risk. Heat stroke cases rise. Waterborne illness follows heavy rain. Disease vectors expand their geography. Budgets and personnel tilt toward emergency readiness. Communities adapt to a higher baseline of environmental stress. After decades of adjustment, the world found a new equilibrium. Coastlines redrawn, maps revised, lessons updated. New urban centers rise inland. Economies grow more regional. Efficiency, conservation, and resilience become standard practice. The world is hotter, seas higher, weather livelier, and life goes on, predictably enough to plan. This new stability is not an endpoint. It is a baseline for what comes next. The deep ocean, charged with heat, will shape centuries to come. The most pressing questions require measurement and foresight. How quickly do these glaciers retreat? And what does that mean for sea level planning in the next century? How will marine ecosystems reorganize, from krill to cod? Which defenses endure, and which simply buy time? These are not academic. They are for the generations already here. Investments in observation and international agreements manage shared resources. Freshwater, coastlines, and grids become cooperative engineering projects. Will we continue to share knowledge or compete under pressure? Thinking on geological time widens the horizon beyond any single cycle. The future is an unwritten chapter shaped by wisdom, foresight, and collective action. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.